The 2nd of December, 2021, deep in the Timor Sea, hundreds of kilometers away from the nearest land, something went terribly wrong. A massive industrial city floating in the middle of the ocean suddenly lost power. Not a small ship, not a simple offshore platform. A 488-meter low NG steel giant carrying hundreds of people had gone 293 workers were now trapped on one of the most remote industrial facilities on Earth. The fire itself was not the biggest problem. The flames were contained. Nobody was killed. But then something happened that engineers never expected. The electricity did not come back. Not after an hour. Not after a day. Not even after 3 days. The ventilation stopped. The water systems began failing. Temperatures inside the living quarters climbed toward 40 degrees Celsius. Some areas reached 45 degrees. Workers had to carry diesel fuel through narrow corridors just to keep emergency generators alive. And beneath their feet was the most dangerous part. Thousands of tons of natural gas, frozen at -162 degrees Celsius. This was not just a machine. It was one of the largest floating structures humans had ever built. A steel city longer than 4 football fields, a factory that could produce energy while floating in the middle of the ocean. But here is the strange part. The biggest challenge was never building it. The biggest challenge was whether it could ever leave, because this entire $10 billion project was built on a simple promise. When the gas beneath it runs out, the factory would move. It would disconnect from the seabed, travel to another gas field, and start again. But there was one problem. Nobody had ever done that before. For more than 100 years, the energy industry followed the same formula. Find a resource, build a factory nearby, connect everything with pipelines. It worked everywhere, until engineers discovered a gas field that broke the rules. In 2007, Shell found a massive natural gas reserve in the Browse Basin, off the northwest coast of Australia. The numbers were impressive, around 3 trillion cubic feet of natural gas, enough to become a major energy source. But the location created an impossible problem. The gas was sitting beneath 250 meters of ocean. The nearest city with a port and roads was almost 475 kilometers away. Building a traditional gas project would require enormous underwater pipelines, a giant LNG plant on land, roads, electricity systems, worker facilities. Before making any money, billions of dollars would already be spent. And this is where the entire idea changed. The engineers realized something. If you cannot bring the gas to the factory, bring the factory to the gas. That single decision created one of the most ambitious engineering projects in modern history. At first glance, a natural gas factory is not a simple building. It is a massive industrial complex. On land, these facilities can spread across hundreds of acres. There is room for giant machines, endless pipelines, cooling systems, storage tanks, and maintenance areas. But Prelude FLNG had to fit everything onto a floating platform in the middle of the ocean. The engineers were not just building a factory. They were shrinking an entire industrial city. And then they had to make that city survive waves, storms, and decades of isolation. The final design became something unlike anything humans had built before. A floating structure stretching 488 meters long, wider than a commercial airplane's wingspan. Rising 105 meters above the ocean, a 30-story building turned sideways and placed in the middle of the sea. At full capacity, it weighs around 600,000 tons. That is roughly the same as 6 of the world's largest aircraft carriers combined. Inside this steel giant are thousands of kilometers of electrical cables, cable to stretch from Barcelona to Moscow. Its storage tanks can hold an enormous amount of liquid, the equivalent of about 175 Olympic swimming pools. But this size was not created to break records. It was created because the ocean creates a completely different set of problems. A normal factory on land can expand outward. A floating factory cannot. Every square meter matters. The deck of Prelude FLNG is only 74 meters wide. So engineers had to completely rethink. Instead of spreading machines horizontally like a traditional factory, they stacked them vertically, layer by layer, like building a skyscraper inside a ship. Some of these industrial modules weigh more than 50,000 tons, and even after stacking everything possible, there was still not enough space. So engineers turned to the ocean itself. One of the biggest challenges in LNG production is cooling. Natural gas must be cooled down to -162 degrees Celsius before it becomes a liquid. On land, Huge cooling systems take up enormous amounts of space, but Prelude FLNG had no room for them. So engineers used a solution that only the ocean could provide. They installed massive pipes. These pipes reach 150 meters below the surface, into the cold, deep ocean. Every hour, the system can pump around 50 million liters of seawater through the facility. That is enough water to fill about 22 Olympic swimming pools every hour. The cold seawater absorbs heat from the liquefaction process and returns back into the ocean. By using the ocean as a natural cooling system, engineers removed massive equipment from the deck and saved valuable space. But there was still one final problem. A factory on land sits on solid ground. It does not move. It does not rotate. It does not fight waves. But Prelude FLNG is different. This 600,000-ton city has to survive storms while staying connected to a gas field below. So engineers had to answer a question no traditional factory had ever faced. How do you keep the largest floating factory on Earth in exactly the same place for 25 years? A factory that weighs 600,000 tons sounds like something that should never move. But Prelude FLNG was never designed to fight the ocean. It was designed to work with it. The engineers realized something important. You cannot stop the ocean. You can only learn how to move with it. The solution was hidden inside the center of the platform. A massive steel column rises 93 meters through the heart of the structure. This column connects the floating factory to the sea. But here is the clever part. The factory is not locked in one direction. The entire 488-meter structure can rotate around this central point. It is similar to a giant door turning on its hinges, except this door weighs 600,000 tons. When storms arrive, the wind and waves naturally push the platform around. Instead of resisting the force of nature, Prelude FLNG turns itself. The bow automatically faces the strongest weather. No engines, no crew control, no constant adjustment, just physics. It works like a giant ocean-sized weather vane. A normal weather vane may weigh a few kilograms. This one weighs hundreds of thousands of tons. But keeping the factory in position was only part of the challenge. The platform also needed to stay connected to the gas field beneath it. Inside the central column are pipes carrying natural gas from the seabed to the surface. A special rotating connection allows the bottom section to remain fixed while the floating factory turns above it. The gas keeps flowing. The structure keeps rotating, and the connection remains sealed. To survive the harsh environment of the Timor Sea, the entire mooring system was designed for an extreme scenario, a storm that might happen once every 10,000 years. 16 massive anchor chains connect the platform to the ocean floor. Each chain is made from enormous steel links. Each link is almost 1 meter long. The entire system contains around 25,000 links. Together, the chains stretch for about 17 kilometers. At the bottom, giant piles are driven 250 meters into the seabed. Each pile is 65 meters long and 5.5 meters wide. This is not a normal anchor system. It is closer to building a giant underwater foundation. But after solving the problem of staying still, engineers faced another impossible question. How do you move a 600,000-ton factory across the ocean? Because Prelude FLNG does not have engines. It cannot sail. It cannot simply drive itself to a new location. The answer was simple, but incredibly difficult. You tow it. On the 29th of June 2017, one of the most complicated ocean transportation missions in history began. Before the massive structure could even leave the shipyard, 9 additional tugboats were needed to guide it through narrow waters. After that, 3 powerful ocean-going tugboats took over. Ahead of them was a journey of nearly 5,800 kilometers. No port stops, no repairs, no easy escape. The entire convoy moved at only about 5 knots. Walking speed compared to the size of the machine being transported. On board were around 160 crew members and engineers. Their mission was simple: protect the largest floating factory ever created. The operation was led by Captain Alan Stockwell, a sailor with 4 decades of experience. He described the mission as the greatest tow of his career. The convoy crossed the East China Sea, passed around Indonesia, and finally entered the Timor Sea. After about 1 month at sea, the giant finally reached its destination, but arriving was only the beginning. The platform still had to connect with the 16 anchor chains waiting on the seabed. Then engineers had to connect the underwater gas wells, test every system, and prepare the floating city for production. More than a year after arriving, the first natural gas finally entered the facility. In December 2018, the largest floating LNG factory on Earth officially began operation. Building the largest floating LNG factory on Earth was only half the challenge. The next question was even harder. How do you operate a massive energy facility in the middle of the ocean? Without a port, a traditional LNG plant, ships arrive at a fixed dock. The land does not move. The equipment does not move. Everything happens in a controlled environment. But Prelude FLNG had none of that. No coastline, no harbor, no protective breakwater, only open ocean. To load its products, LNG carriers had to approach the floating factory directly. AA-290, meter-low NG transport ship, would slowly move alongside Prelude FLNG together. The two steel giants would weigh nearly 1 million tons, and both of them would rise and fall with the waves. Between them, special cryogenic loading arms would transfer LNG at -162 degrees Celsius. This was not a normal port operation. It was a floating port built in the middle of the ocean. And then, the ocean reminded everyone who was really in control. In May 2018, during one loading operation, disaster nearly happened. An LNG carrier named Galena was approaching Prelude FLNG. The ship was preparing to connect and begin the transfer process. Then, suddenly, a towing line broke. At that moment, only about 50 meters of clear water remained beside the facility. Another mooring line also failed. The entire operation had to be stopped. No LNG was transferred. But the most worrying discovery came afterward. When engineers inspected the system, they found that all 16 mooring lines had suffered serious damage. The cause was a design problem. Sharp edges inside guiding equipment had slowly worn down the chains and cables, a problem that engineers had not fully considered during the original design. The Australian Maritime Safety Authority later warned that, under different circumstances, the entire mooring system could have failed. And if that had happened during LNG transfer, the consequences could have been catastrophic. Eventually, the system was repaired. On the 11th of June, 2019, the LNG carrier Valencia Knudsen arrived. It collected the first shipment of LNG from Prelude FLNG after 8 years of planning, construction, and delays. The floating factory finally delivered its first energy cargo. But the real challenges were just beginning, because living on Prelude FLNG was unlike working anywhere else on Earth. This was not a factory where workers went home after their shift. This was an isolated city in the ocean. Around 220 people lived and worked there during normal operations. Engineers, firefighters, doctors, chefs, maintenance specialists. Zevrione depended on the platform. The nearest hospital was more than an hour away by helicopter, so the facility had to prepare for almost every emergency itself. It carried free-fall lifeboats on its sides. Each lifeboat could hold 70 people, and they could be launched from a height of 40 meters. But even with all these systems, one question remained: what happens when something breaks that cannot simply be repaired? A normal ship can return to a shipyard. A factory can shut down and bring in replacement equipment. But Prelude FLNG has no such option. It cannot simply sail away. It cannot enter a dry dock. It is permanently connected to the gas field beneath it. Every major repair must happen in the middle of the ocean. And that design choice would soon become its biggest weakness. For a project worth more than $10 billion, failure does not always come from a single disaster. Sometimes, the biggest threat is much quieter. A system that does not work as expected, a problem nobody predicted, or an idea that sounds brilliant on paper, but becomes much harder in reality. That was the story of Prelude FLNG. In February 2020, the floating factory suffered a major electrical failure. Production stopped completely. The export of energy products stopped. A facility built to operate for decades suddenly became silent. The shutdown lasted almost a year. It did not return to normal operations until January of the following year. But the most serious crisis was still ahead, the 2nd of December 2021. The same night we started this story, a small fire broke out inside a backup power area. The fire itself was controlled, but the consequences were much larger. The entire facility lost power for 3 days. Workers fought to restore the electrical system, but they could only achieve short periods of temporary power. When Australian regulators arrived to investigate, they discovered a deeper problem. The issue was not just the fire. It was the complexity of the system itself. Investigators concluded that the operating team did not fully understand the design logic of the facility's power system. They also found weaknesses in how the system responded during failures. And losing power on Prelude FLNG was not just an inconvenience. It created a dangerous situation, because inside the ship were enormous tanks of LNG kept at -162 degrees Celsius. Without electricity, critical pumps could stop working. Those systems were responsible for controlling temperatures around the cryogenic storage areas. Without proper cooling control, nearby steel structures could become dangerously cold. And at extreme temperatures, steel can lose its flexibility. It can become brittle. A material that once supported a massive floating city could suddenly become vulnerable. Regulators warned that without the right actions, the situation could have developed into a catastrophic structural failure. The number of people on board was reduced from 293 to 137. Production was suspended until the problems were addressed. But this was not the end. Prelude FLNG continued facing challenges. In the summer of 2022, the facility shut down again because of a labor dispute. Later that year, another small fire interrupted deliveries for several weeks. In August 2023, the first major full-scale refurbishment began. The repairs lasted for months, and as engineers worked, more problems appeared. By the middle of the 2020s, the company was still working on improving the management and operation of the facility. And this raises the biggest question: was Prelude FLNG a failure? Or was it simply a technology that arrived before the world was ready? Because the original idea behind this project was never just about building one giant floating factory. It was about creating a new generation of mobile energy infrastructure. Traditional LNG plants have one major weakness: they are trapped. Once built, they belong to one gas field. When the resource disappears, the factory loses its purpose. It becomes a massive industrial monument. But a floating LNG factory promises something completely different. A gas field ends. Move the factory, disconnect from the seabed, travel to another location, start production again. The factory would outlive the resource beneath it. That was the dream. The plan was ambitious. Build many similar floating LNG facilities. Create a new era of mass-produced offshore factories. But reality changed everything. By 2016, those future projects were canceled. The second Prelude style facility was never built. The dream of mass production disappeared. Instead of becoming a new industrial standard, Prelude FLNG became a one-of-a-kind experiment. But the second gamble remains, the one that truly decides the future of this technology. Can it actually move? The engineers designed the system for relocation. The models say it is possible. The plans show how it could happen. No one has ever disconnected a 600,000-ton floating factory from the seabed and moved it to a new gas field. One day, if Prelude FLNG reaches the end of its current gas supply, engineers will face the ultimate test. They will need to disconnect 16 giant anchor chains, separate the underwater gas connections, protect the cryogenic systems, move a 600,000-ton structure across the ocean, then reconnect everything somewhere else. And the biggest question is not, can humans do it? The question is, will it make economic sense? Because if moving this giant costs more than building a new one, then the entire idea loses its greatest advantage. Today, nobody knows the answer. Not regulators, not contractors, because there is no previous example. Prelude FLNG was never just about being the longest ship, or using the most steel, or breaking engineering records. Its true purpose was to answer a much bigger question. Can humanity change the way we develop the oceans? For a century, the rule was simple: bring resources to infrastructure. But Prelude FLNG introduced a different idea. Bring infrastructure to resources. A 488-meter steel city floating in the Timor Sea. A $10 billion experiment. A machine designed to prove that a factory could have a second life one day. The answer will finally come. The day when 16 massive chains release from the seabed. The day when this 600,000-ton city moves for the first time. If it succeeds, Prelude FLNG will prove that a factory can truly move like a ship. If it fails, it will become something else. A monument to human ambition. A reminder that humans can build the largest structures on Earth, but still struggle to control their destiny. Because the final question remains, is Prelude FLNG the future of energy? Or is it a billion-dollar monument permanently floating in the ocean? Only time will tell.